percentage of the atoms by the respective atomic masses, what you get is relative number of atoms. Now if you divide the percentage of carbon, which is given as 81.6, by its atomic weight, that is 12, then the relative number of atoms will come out to be 6.8. Similarly, if you divide the percentage of hydrogen, that is 4.8, by its atomic weight, which is 1, what you will get is 4.8 as the relative number of atoms of hydrogen. Now if you divide the percentage of nitrogen, which is 13.6, by its atomic weight, that is 14, the number you get is 0.97 as the relative number of atoms. Now to determine the empirical formula, first of all, what we do is that once we get the relative number of atoms, then we see that which atom has got the least relative number of atoms. So in the next step, that is to determine the simplest ratio of the element or of the atoms in the empirical formula, what we do is we divide the relative number of atoms by the lowest number, and that number is nothing, that is the atom which has the lowest relative number of atoms. So what you do is basically, in simple words, is that you divide the relative number of atoms by the lowest relative number of atoms. So if you divide the relative number of atoms of carbon, that is 6.8, by 0.97, which is of nitrogen, that is N, then the figure which you get is basically 7. So therefore, when 6.8 is divided by 0.97, the number we get is 7. Similarly, if you divide the relative number of atoms of hydrogen, again by the lowest, simplest, or you can say the lowest relative number of atom, that is of nitrogen, equals to 0.97. So therefore 4.8, that is relative number of hydrogen atoms, divided by 0.97, that is the relative number of atoms of nitrogen, the simplest ratio or the number which we get is 5. Now when you divide the relative number of atoms of nitrogen, that is 0.97, by 0.97, the simplest ratio we get is 1. So what we can clearly say is that the carbon as 7, hydrogen as 5, and nitrogen as 1. So therefore the empirical formula will be C7H5N. Now it is also given that the vapor density of the compound is 51.5. So therefore, to determine the molecular formula, what we need is the molecular mass of the compound, because as we know that the molecular formula of any compound equals to empirical formula into N, where N is equals to molecular mass, divide it by empirical formula mass. So therefore, if you have a vapor density as 51.5, then by the relation between vapor density and the molecular weight is this, that molecular weight is twice of the vapor density. So therefore, in this case, the molecular weight of this molecule or the substance will be twice of 51.5, which will come out to be 103, that is 103. And similarly, if you see the empirical formula of the compound, that is C7H5N, when you find out the mass of this empirical formula, what you get is the empirical formula mass. So therefore, the empirical formula mass will be calculated as 12 into 7, whereas 12 into 7, where 12 is the atomic mass of carbon and 7 are the number of carbon atoms, plus 1 into 5.